Let's move on to the portable drills in this segment. There's some parts I want you to be familiar with. Now, whether you're using the electric version or corded version versus the cordless, they have a lot of these parts in common. They're both going to have a chuck. We've already discussed, but you got a keyed versus keyless chuck, depending on the manufacturer. You're going to have some sort of handle. You got your motor area. And the thing you need to pay attention to with the motor area is they have vents, and each manufacturer is going to have the vents in a different place. Don't cover those up with your hand when you're holding the drill, because you'll actually cause it to overheat. Trigger. Some drills are equipped with trigger locks, so make sure before you plug a drill in, if it's an electric with a cord, that you check to make sure the trigger lock's not engaged. Forward and reverse switch, going to be in different places depending on the manufacturer. Right there on this particular electric model, above instead of in front on this cordless model. Speed selector. This drill doesn't have a speed selector because it's what they call a variable speed drill. The harder I pull the trigger, the faster it spins. Now this one has a very slow setting and either slow or fast. The slow speed's designed to have high torque for inserting screws, and the high speed setting is for just simply drilling holes. Another feature that this one has that the corded doesn't is a clutch. The clutch registers how much torque is required. For example, it takes more power to put the head of the screw into the board than it does the shaft. So once it engages to a certain point, the clutch and the head hits the surface, the clutch will engage and causing the chuck to stop. That way you don't bury it too deep, busting through or splitting or stripping your wood. The last thing, the cordless drill doesn't have it because of the type of chuck, but on a key chuck, you're going to need some sort of chuck key. And a good place to keep it is attached to the cord. This forces you to unplug it, which is a good safety policy, but it also keeps you from losing it, getting damaged. Now, when it comes to power tools, you need to read the owner's manual, be aware of all the safety operations, follow all lab safety procedures that go along with your tool. Knowing how to use your tool safely is going to prevent any accidents from occurring. And there's no more important safety rule than to wear your safety glasses. Okay, let's set up to drill a couple of holes here. I want to make sure my work is secured. I want to check my bit type. I'm simply drilling a 5/16 or 3/8 hole here. So I've got it installed correctly. It's centered. It's to the proper depth. The jaws aren't grabbing the cutting flutes. If this was the corded drill, I'd check to make sure the trigger lock's not engaged. Now I'm going to position it in place. And I'm going to use two hands. The one hand obviously is for operating the trigger and the handle, but the other hand's for stability. Keeps it at the proper angle. Okay, the drill is right or left-handed. It's not, it's universal. All right, let's drill. Something's not right. The hole's got some burning in it, the bit's hot, obviously I've got some smoking. What could be the causes? Well, if I forgot to check or the drill's in reverse. That's one reason. Another one is, say you just throw your drill bits into the toolbox. They get damaged, they get chipped, they get dull. You've had it around for 10 years. It's Grandpa's bit, so it could be dull. On the drill press, use larger bits. Sometimes you could be pulling the lever too slow, causing it to overheat and burn the work. If you noticed, before I pulled that trigger, I had it touching the work. Okay, this is the only tool in the workshop that you're going to be, the tool being touching the work before the trigger or switch is engaged. So let's go ahead and drill the second hole. If you notice, when I clamp this, I clamp the scrap piece of work below. That's to protect the workbench. How I'm positioning again, two hands, but you notice my elbows. They're against my body. Just in case I hit a knot or something hard and the drill would lock up, I've got some stability. Now, I'm not standing flat-footed, feet together. You can't really see it, but my feet are off-centered, a little bit spread apart. So body position is important. Let's drill this hole. Forgot to change my clutch setting. Okay, everything went pretty smooth. Let's drill another hole. Okay. Say I didn't want to go all the way through. I could apply a piece of masking tape. It's not a guaranteed accurate way to control the depth of cut, but at least it gives you a guide, like for if you're drilling a cup hinge or adjustable shelf pegs. Now, I mentioned that the scrap piece was below for protecting the workbench. It also serves another purpose. If you notice, the holes that are above the scrap piece have a clean, smooth bottom. The holes where I didn't have a scrap piece below have chip out. This is simply because you're putting pressure on the board and you're removing material. The material doesn't have the resistance that it had when it was thick to prevent breaking or splitting. So by adding that scrap piece below, it allows the resistance the board needs. A couple other notes on the drills, or portable drills. These are engaged with a brake. That's a feature you need to look at if you're purchasing a drill. It's hard to insert a screw if the screw doesn't, or the drill doesn't stop as soon as you let go of the trigger. Most quarter drills don't have brakes and they'll spin to a stop. They're designed really for drilling holes only. Variable speed versus 2-speed. We've talked about that one a little bit, but again, the faster I pull or harder I pull the trigger, the faster the drill goes. Where this one has a speed selector. And another quick review is the clutch setting. The amount of clutch setting is a variable. It's not really a definite number. Some manufacturers will have 12, some will have 20, 24. It's all just how many different settings it has. But the lower the number, the more resistance it has and the quicker the clutch will engage. All right, let's move on to the impact. The impacts are simply designed for inserting and removing screws. Again, my work's clamped. If I'm screwing a board to another one, I'm going to have them clamped together for security purposes, so to speak. All right, now here's where the safety rules are going to change a little bit. You notice my hand's not in position. I need to get the drill bit started, or the screw started. If I pull the trigger just a little bit, it slowly moves. Okay, these are designed to do that. So I'm going to hold the screw up by the head where there's no thread so I don't hurt myself, and get the screw to engage. Once it engages, I'm going to reposition my hands. Now you heard that clicking sound. That's actually the impact working to give you a little bit of extra power. It's often confused with stripping, which is something we need to address also. You need to keep the bit in line with the fastener. A lot of times you'll hit a hard spot in the wood and the screw will start off at an angle, and the operator simply forgets to change the angle of the drill or the bit, and you end up not being at a proper angle. I'm exaggerating here, but you can see how this would strip the bit. So keep it, if the screw moves, adjust the head of the drill with it. All right, let's go ahead and insert the screw. Okay, everything went as planned. Now, say you get a split near the end. You have to put a screw in the end of the board, and you get a split. How can I prevent that? It's a simple technique called a pilot hole, which is simply taking a bit that's just slightly smaller than the shaft of the screw, so it allows the threads to engage, and go ahead and drilling through. Now let's put a screw in there and see how much smoother and easier this one goes. A lot quicker, but also no splitting. Let's review.